All right, how's everyone doing?
Good.
Awesome. So, quick show of hands. Where are my builders? Builders, engineers, any type of builders. Investors. Product people. Engineers. There's no engineers in the audience. You're kidding, right? What about our team of engineers back there, guys? Okay. All right, so we're gonna have some fun today. Over the next 20 minutes, we're all going to be speed running, building a company together, okay? And not just any company, we're gonna build a positive sum AI company. So I'll explain what I mean by that. So if you're familiar with game theory, positive sum game is a game where all players can win. As the total gains exceeds losses, leading to a mutually beneficial outcome or situation where the overall value increases rather than a fixed amount being divided. You may have heard the other two, which is negative sum game as well as zero sum game. So that's not what we're playing today, okay? The players. Players is our company that we're gonna be building. We have our end users, which we'll talk about, our customers, our partners, as well as our investors. And our mission is not AGI, and is to create 100x value for our end users, customers, partners, and investors. Okay, that's the goal.
Who's your partner? Can you define?
Say that again?
Can you define your partner? Who's your partner?
We'll come to that. Okay, just play along. So let's look at the problem in the market first. So the market we're addressing today is the SMB market. So this market, we're solely focused on SMB market less than 10 employees. So this is around 33 million SMBs in the United States. Around 78.5% has less than 10 employees. So do the math in your head right now. And outside of the United States, this number is 350 million. Okay? Second, what is the problem that we're facing today, right? One problem that they're facing today is they're getting an average of 600 calls per month. So for a solopreneur, or people with less than 10 employees, this is very hard to handle. And for a high volume business, they're actually handling something like 3,000 calls per month, right? So you can imagine you need a full-time person or maybe more than one full-time person to be able to handle all these call volume. Most importantly, the missed calls here equals lost revenue. So around 60% are missed calls because these entrepreneurs don't have time to go and pick up phone calls all the time. Just imagine your typical restaurateur, right? They're serving their clients, they don't have time to pick up order calls. Second part is that 85% of these leads do not call back again if the call was missed. So that's our market. What is our solution? So today we're gonna build a voice-enabled platform or product, right? This is around 69% of all business inquiries are still coming from telephone calls. Email is about 15%, text is about 15%, all small fries. Second, this is going to be very private because in our company, we care about privacy. We care about protecting user privacy. We care about having the capability of deploying these private clusters for our customers to protect our end users. Third, we're going to also try to hit this multi-persona concept, right? So if you imagine any kind of small business, they have multiple functions. You may have one receptionist that picks up a call at an auto repair shop. You can also have a claim specialist that helps the user through their claims. And all of those personas are very independent in its knowledge, skill, and the task it performs, right? All right, so we have defined our users. What we know as well is that they have a willingness to pay for $100 per month for 1,000 calls. This is roughly equivalent to 83 hours which equates to $1.2 per hour. I want you to remember that number. $1.2 per hour is where you're earning from this, the revenue that we're making, right? And when we're looking at 1% of market penetration, our company will be making $300 million, which will put us into the unicorn range. Okay. All right, so now I'm gonna engage you guys a little bit. So we're gonna build our MVP product first, okay? There's two requirements that's the most important. One is for our business guys, which is the cost efficiency. Because Eric would like to know how much of this $1.2 can we really be making, right? So Eric, what is a good profit margin for you?
Say it again?
What's a good profit margin for you?
Above 85%.
Great, okay. And then the other vector, of course, because these are calls and people are expecting humans to pick up, we expect the latency to be quite low, right? So we're gonna set a latency target of under 1.5 seconds for any AI to respond to any query. And I'm gonna beat your 85%. This is a 90% margin, okay? This puts us at roughly $10 per user per month and 0.15 per hour cost basis. Also remember that number. All right, so we're gonna now take a stab at building this. The first thing we're gonna look at is how do we build a voice system that has latency of less than 1.5 seconds? Well, I don't have engineers here, so it's a little bit harder to ask this question, but what are the different components that you guys think goes into building a voice agent? So one hint I'll give you is the network component. So this means Twilio, Vonage, if you're integrating into one of the telcos, that's the network component. What else is there? Anyone? I don't know how to speak to non-engineers, but okay. So let's move on. There's ASR component. This is, automated speech recognition. Basically, this is what speech to text is. And then probably for your MVP, you want to build on top of some available LLM API, right? And then also the TTS component. So TTS is text to speech, which is how you translate what the AI says back into the speech to the user. So essentially, what we're looking at here is three types of options. The first option is what I consider SOTA, which is state of art, in each of these categories. So if we compile the state of art versus the lowest latency that we can find in the market versus using a speech-to-speech model from OpenAI, real-time API, this is what we end up with. So the first one, definitely too long for us to use, right? We're looking at Vonage, which puts 600 milliseconds on the network latency. We're looking at DeepGram, 11 Labs, which puts us over definitely that target. The third-party latency is doing pretty well. So if you use something like 10x and DeepGram and InWorld, we get to pretty good latency here. And the reason why I bolded the second one is because we have a lot more flexibility here to swap out components like ASR and TTS, whereas the speech-to-speech model, who is talking? Okay, someone is trying to talk over me. Anyway, so the speech-to-speech model, we don't want to choose that for now because it gives us less flexibility in switching the other components, right? So we did pretty good there. So now let's look at costs, okay? Any guesses who's the winner here? And how much does it cost per hour? Just remember our target is $0.15 per hour. Anyone want to take a guess? Sorry? But my company is not up there yet. We haven't built it yet. All right, so this is what we're looking at here. If we're looking at a call coming in for all of these components compiled together, actually ending up pretty much on the negative side for the SOTA. So we're at $390 cost basis per month. Also on the pretty negative side, in terms of using one of the hyperscaler solutions like Amazon Q, around $200. We're doing much better at the lower latency part. We're actually making a little bit of money, but not enough money to make Eric happy yet, right? But we're somewhere for MVP at $67 per hour. All right, so now we're gonna introduce another player. That's our customers, because Eric and Suma has been doing a very good job getting our major telcos in the US as our customers. So this allows us to do more with less cost, right? So now what does the equation look like? But with great customers come great responsibility. And these customers want private deployments. This means either we're deploying a private dedicated cluster for them on the cloud, or we're deploying into their bare metal purchase from NVIDIA on their on-prem cluster here, right? So of course, we love our customers, so we're gonna build this, okay? So the first thing we're gonna look at is what happens to the cost and the latency on a private cloud cluster. So here, we can actually eliminate the network component because we're not directly integrated into one of the telcos, right? So we're well below our target of 1.5 seconds. In fact, we're below 1 second here, which is pretty awesome, pretty close to real time. And on the cost side, and you want to take a guess here? No one likes to gamble in this cloud, okay. We're actually ending up at 13.86, which is pretty close. Actually, this beats Eric's target, but not quite mine. We get really, really close to that target of 90% margin here, right? But the question really is, can we do better than that? So now, we're gonna enter the beta phase of the product building. We're moving really, really quickly here. Product people in the audience, there's a lot, awesome. What other feature do you think this segment of users will want to see? So the first hint I'll give you is they don't want to just carry a single conversation. However, you want your favorite restaurant to remember the last time you came in. You want your favorite restaurant to remember you're gluten-free, right? So the relationship memory or persistent memory is a huge component of this. What other features can you guys think of that's important for this segment?
Accuracy.
That's a really good one. Yep. Anyone else?
What about scalability?
Knowledge of business.
Knowledge of business, yes.
What
Sorry.
about scalability?
Scalability? Yep, definitely one. Yep. All right, I'll just give you some concrete examples of other features we're happy asked for. One is the action taking. So basically the AI will have the ability to take any action, including being trained automatically and continuously by the owner themselves. It also includes being able to hand off to a human agent when the AI cannot handle the inquiry. A third part is the multi-agent routing that we talked about. So imagine your typical IVR system where you call in and you press 1 to go somewhere, press 2 to go somewhere, press 1 again to go somewhere else. Exactly. So now you don't have to worry about that anymore. You just tell the AI what you want, and the AI knows exactly which personas that should pin, right? All great. So the downside of all these great features is they all add latency, and they all add complexity, and they all add cost, right? But today, what I'll actually talk about, which is the most interesting for me, is something called near-edge deployment. Who's familiar with near-edge deployment? Awesome. Okay. What is near-edge deployment?
It's very close to the customer where you're ending up with almost zero network latency because you're very close to the customer.
Perfect answer. Some people may know, I mean, we all heard of 5G. All of our phones have 5G, right? And NVIDIA has been really pushing for the 6G infrastructure, which is super interesting for us, of course, because it's an AI native infrastructure. And if you think about 5G, when all the compute, when your call comes in, happens on the cloud or on-prem, 6G means everything is happening distributed near edge. So this is essentially like a picture of a telephone tower. Just imagine there's these GPUs sitting in the telephone tower, being able to run your calls very, very, very close to the end user or the SMB that we care about, right? And I know John speak a lot about AI RAN before, so that is a AI native platform that enables things like visual, calling, video, etc. at very, very low latency. And where does LLM come in? It's the first time I said that word today. Is if you think about LLM, one of the corollaries of these machines is none of them will be able to really run a large language model because they take too much compute, they take liquid cooling, they take parallel computing, and you cannot distribute them into thousands and thousands of data centers, right? So what we end up with is we need to be able to run these models, much, much, much smaller and more specific models on something like a Llano box, RTX 6000, L4DS. So those are our compute parameters, right? So we have to work ourselves into these smaller models. So what is really interesting about small language models is they're either domain specific or in our case, business specific. And they're usually only around 1 to 2 billion parameters. Who knows how many parameters GPT-5 has? 675 billion parameters, okay? And this gives us efficient compute. It can run near edge, cost effective, it's much, much cheaper to run. So a Blackwell is $40,000. A RTX 6000, I believe today says at $7,000 if you order it. And it's very easy to train and customizable, and someone said high accuracy. So the small language model also give you more precise control and higher accuracy to be trained on small language data. Yes?
The question I have is when you start to build an application, you probably don't know like the exact parameter you may end up with. And as application evolve, the more feature you add on because you want to offer more functionality to users, then the complexity evolve, and then you add more. So my question is like when you think about this near edge deployment with SLM, like what are the things you have to put in a framework in order for this to work? Because you don't want to start something and then 10 months later you find out that this doesn't work. You require much complex architecture.
Yeah, I understand what you're saying. So I think the typical understanding is for these infrastructure, I'm sure you've heard of mixture of expert models, right? Essentially the idea is it depends on what your task is, it will route to a smaller expert, right? So it's very similar in that format of what you're thinking about, but as long as what you have built in terms of infrastructure allows these systems to talk to each other or these models to talk to each other, you can always add functionality as if you're adding a module, right? All right, so moving on. So now we have our partners, NVIDIA and the OEMs, right? So they give us the power to be able to run near edge. Okay, again, I know you guys don't like guessing, but here's what we ended up with, okay? We started with our MVP product, which we were at $68 per hour for this thing to run, per month for this thing to run. The second part is we ended up with alpha product. On the on-prem, we already got 50x better. That's pretty good within 15 minutes, right? For near edge, however, how much gain do you think we got to? And I'm not even asking for a number, like magnitude. Pretty close. We get to 700x. So reason the third role is highlighted is because that's where we're today. We have deployed this and we have tested and we feel pretty good about the 50x and we're going towards the future of the 700x.
Who maintains and supports this hardware?
Sorry?
Who maintains and supports this hardware that's at your edge?
Yeah, so for example, if a telco has a lot of these towers and have bought a lot of machines, they would be maintaining them. So essentially what we have built today is our personalized AI receptionist, which we have been working on for the past year. So I just want to thank our partners, customers, majorly our team for working on this, of course, for much harder and longer time than we have spent today. And we built something 50x better, right? And what we're building towards the future is on the edge, putting every small business, every person's personal AI on the edge. I know there's no engineers, so I'm not gonna say this, but if you know any engineers, please scan that. And if they wanna build something that's 100x better with us, please recommend them to join us. Thank you.